Most finance professionals using Claude are still building workflows that rely on manual triggers. So you prompt, you get an output, you copy it somewhere, and then you repeat that same process next week and probably the week after that, and so on and so on. Now the analysis is solid, but the execution is still always on you. So in this video, I'm going to show you how to build an AI agent with Claude that actually works on its own as a finance analyst, running continuously in the background, monitoring your operational data around the clock and delivering structured financial reports directly to your WhatsApp without you touching a thing. And this isn't a scheduled Claude task or a simple skill setup. This is a true AI agent that removes the manual layers so that you can focus on decision making instead of execution. The agent I built lives on a server 24/7. It watches your operational data for new business days, and the moment a new day appears, it generates a full daily brief and sends it directly to you. So on Fridays, it also produces a structured weekly finance pack as an Excel file and delivers it in the same way. Now remember, if you want the prompts and the workflow files from this video, they're in my free community and the link is in the description below. So let's get into it. Right, so before the build, let me tell you what we are using and why I like to use it. So Claude is the intelligence layer and it does the actual finance work. Now the limitation is that Claude does not run on its own. You have to be there to start the conversation. So we're integrating Claude in an agent platform called OpenClaw. And this is what turns Claude into an agent rather than just a usual chat session with its own tools, its own destination, and the ability to run on its own without anyone prompting it. Now, an agent like that needs to live somewhere that is always on. Otherwise, the moment you close your laptop, the agent then just dies. So that is where Hostinger comes into it. Now, this might sound a bit complicated to start, but trust me, it's not. And I made it really simple so that even if you're a beginner Claude user, you can follow this. Now, Hostinger lets you deploy OpenClaw without manually configuring a server. So if you go to the OpenClaw page through the website, link is on the screen now, you'll see two options. You'll have managed OpenClaw and OpenClaw on VPS. Now for this setup, you should use the managed OpenClaw because I don't want to manage the infrastructure myself. I want to make it easy. So Hostinger handles the setup, it handles maintenance, security, updates, backups, all that stuff so that the agent can stay online 24/7 and importantly, without me touching anything in the back end. So when choosing the plan, I'd go with 12 or 24 months because it's much more affordable long-term compared to paying monthly. And you can also use their discount code, which is on the screen now as well. So after that, I go into Hostinger's application panel. I find OpenClaw in the list and I click setup. Now the whole point is that I don't need to manually install Docker or configure a server or deal with terminal setup. Hostinger handles the deployment. So once I click setup, the configuration page asks me to choose an AI provider. So I select Anthropic because the agent will run on Claude. Now that then triggers a prompt for an API key. So to get that key, I open a new tab to the Claude platform dashboard. Then I click into the API keys section in the left sidebar and I click create key. I then name it OpenClaw and I add it. Claude then generates a new key. I copy it, I switch back to Hostinger tab, paste it in, and then I click next. After that, OpenClaw completes the initial setup and then it generates its own access credentials. So I store those in a safe place because they control access to the environment. Now, when the OpenClaw application opens, I get a chat interface with model options at the top. Claude Haiku, Claude Sonnet, and Claude Opus are all available. So for the setup prompts, I switch to Claude Opus. Now that is intentional because the initialization steps are really where the entire system architecture gets defined. So if there's any ambiguity here, it kind of propagates forward. So I want the highest capability model handling this part. For the continuous loop that comes later, the agent will run on a lighter model to just keep costs in check. Now, the last setup step is connecting WhatsApp. And this is how the agent will deliver every output once it's running. So I tell OpenClaw that I want to connect my WhatsApp. It generates a QR code. I then open WhatsApp on my phone. I go to settings, I choose add a new device, and I scan the code. And the connection is complete. And then from this point on, every message and every file the agent produces will go directly to my WhatsApp. Now, before starting the actual agent build, I type /reset in the chat to clear any prior context. So this gives me a clean foundation so nothing from a previous session carries over unintentionally. The system is now ready to receive its first instruction. Building the agent architecture. Now, before we get into the prompts, let me just walk you through where we're going so that all this makes sense as we go along. So first, we have to bring the agent to life inside OpenClaw, which means spawning it and giving it the tools that it needs. Now, once it exists, we have to teach it to read the data that will be coming through to it. So once it can read, we teach it the daily analysis and the weekly analysis. Then we connect it to WhatsApp so it can actually deliver what it produces, and then we'll run a full trial. So let's get into it. Now, the first real prompt defines everything the agent needs to function. So I spawn a sub-agent, which is Fin_Analyst, and then I wire it up full capability set in one instruction. Now, the prompt here connects the agent to the system API so it can read live operational data and gives it local file system access so it can write Python files and then generate Excel workbooks. Now, it also enables Python execution so that those scripts can actually run, and it provides my WhatsApp number as the delivery destination so that the agent can send the daily brief and the weekly Excel directly to it. I also configure it to maintain persistent state across turns, which is what allows it to run a continuous loop without losing context between each cycle. Now, OpenClaw processes the request and returns a confirmation listing the sub-agent name, the tools connected, and the WhatsApp delivery endpoint. So I can now see it in Fin_Analyst as a separate agent in the interface. Now I switch into its dedicated chat, which is where all subsequent work now will happen going forward. So the main assistant acts as the controller. So this agent is the one that will be doing the actual work. Now I need to keep them separate because that makes responsibilities clear and the system easier to manage going forward. Now at this point, the agent exists, but it has no financial logic. So the next prompt builds the skeleton. So instead of asking it to build everything in just one go, I'm forcing it to lay out the architecture first. So every function that the agent will need is created as a stub that returns nothing. And the constants are defined at the top, including my WhatsApp number as the messaging destination, and the entry point, calls a main loop that just prints a confirmation and exit. Now, the reason I build the skeleton first is just architectural clarity. If I ask the agent to implement everything at once, it tends to shortcut the structure or compress logic in ways that then creates problems later on. Now, by defining the shape of the system in advance, every subsequent prompt has a clear home for what it builds. So I run the skeleton and I confirm it executes cleanly, with 0 errors before I move forward. Implementing the financial logic. The next step focuses on one function only, fetching the data. Now, everything the agent does eventually depends on this. So isolating it before any analysis logic gets written is what keeps the rest of the build clean. Now, the instruction tells the agent to call the system API for all 13 tabs in a single batch request and return the result as a structured object where each tab has its title, headers, and rows. I'm also explicitly telling it to print a one-line summary per tab with row counts so that I can verify the numbers match the source. Now, the agent runs the function, and during the test, it identifies that the data structure includes a title row above the headers. So it adjusts its parsing to handle that. It runs the validation, and then it reports back with row counts. Now, the numbers match the expected ranges, which means every analysis function from here on is working off real, correctly parsed input. Now, the daily layer is what gets sent every business day. It covers 3 components that together show where the business stands at the close of that particular day. So this step implements the 3 daily analysis blocks and the message formatter that combines them. Now, the KPI pulse captures revenue, margin, procurement spend, and inventory value for the current day. The cash and working capital function computes net cash movement, open receivables and payables, and the 4 efficiency metrics. The anomaly function checks operational data against the configuration thresholds and flags anything that breaches them, returning each issue with a severity level, a dollar impact, and the specific source reference behind it. Now, the formatter takes those 3 outputs and assembles them into a fixed structure daily message. So date at the top, then KPIs, then the cash block, then the anomaly block. So every output shape is defined this strictly because the daily message has to look identical day to day. The numbers are going to change, but the structure does not. It can't. Now, the message is compact enough to read in under a minute, but specific enough that a CFO can immediately act on it if necessary. So I run a full test at this stage. The system fetches live data, it calculates all 3 blocks, and then it prints the formatted daily message. All numbers are populated, the formatting is clean, and the anomaly section cites real operational references. So that looks like the daily layer is complete. Building the weekly intelligence layer. Now, the weekly layer is where the system moves from monitoring to analysis. Now, daily reporting tells you what happened today, but weekly reporting explains what it means across time, and it connects it to decisions. So I implement all 5 analytical modules plus the executive summary in a single prompt, defining the exact output structure for each one. Now, the margin and purchase price variance model, or module even, compares this week's revenues, gross margin, and procurement spend against the prior week, and it identifies the most significant price variance events and surfaces which suppliers or purchase orders are driving them. The working capital module builds on the daily metrics but adds trend context, whether inventory days, sales days, and payable days are improving or deteriorating, and how that affects the cash conversion cycle across the week. The supplier scorecard ranks vendors by risk using a combination of price, variance frequency, freight cost spikes, and volume concentration. So a supplier with multiple price variance breaches and freight volatility gets flagged as a high risk if individual order values look normal. Now, this is the kind of signal that gets missed when you look at vendors one order at a time. The budget versus actual module compares weekly operational spending and revenue against the monthly plan, then projects where the full month is likely to land based on the current run rate. Now, this is where financial discipline becomes visible. A department that has already consumed 40% of its monthly budget in the first week shows up clearly here. Now, the strategic actions module synthesizes everything into a prioritized list of recommended steps. So each action includes an owner, an expected outcome, an estimated financial impact in dollar terms, and a timeline. Now, the point of this section is not to describe problems. Those are already described in the 4 modules above. But the point here is to tell leadership exactly what they can do about these problems. Now, the executive summary pulls from all 5 modules and the daily data to produce a top-level view of the business. And each area gets a status indicator, a key metric, the actual value, a target, and a 1-line assessment. Now, this is the first tab finance teams open, and it's designed to communicate the overall situation in less than 2 minutes. Once all 6 functions are confirmed with real data, I implement the Excel builder. Now, the instruction tells the agent to take all 6 dictionaries and write them into a single workbook with 1 tab per section, the file path including the simulation date in the file name, the executive summary always first, and the rest of the analysis in sequence. The agent runs the build, produces the file, and confirms all 6 tabs are populated. Now the file opens cleanly, executive summary at the front, then margin and PPV, then working capital, suppliers, budget versus actual, and then the actions list is at the end. Connecting delivery and running the trial. At this point, the system can produce both outputs, but it cannot deliver them. So the next prompt implements the 2 delivery functions, one for sending the daily text message and one for sending the Excel file as a document attached, both targeting my WhatsApp number, which the agent already has from the earlier setup. Now, before going live, I run a full trial. The system fetches current data, builds the daily message, prefixes it with a trial marker, and then sends it. Then it builds all 5 weekly modules, generates the Excel file, and sends that as an attachment with a caption showing the reporting date. Both deliveries confirm success. When the message arrives on my WhatsApp, it shows revenue, gross margin, procurement spend, and inventory value at the top. Below that, net cash movement for the day, open receivables and payables, and all 4 working capital metrics. The anomaly section lists each firing alert with its category, a 1-line description, the dollar impact, and the specific operational reference behind it. Now, this is exactly how a finance analyst would communicate urgent information to leadership, but it's fully automated and arrived without anyone running anything. Now, the Excel attachment is where you can see the scope of the depth. 6 tabs, each representing a different layer of the weekly finance review. The executive summary gives leadership the overall picture in seconds. The margin and purchase price variance tab shows where profitability is being affected and by how much. Working capital tracks the efficiency metrics across the week. The supplier scorecard surfaces concentration and reliability risks. Budget versus actual shows where the month is tracking against plan. The actions tab turns all of it into concrete next steps with ownership and also expected savings. And so what would normally take a finance team at least several hours to compile and format arrives automatically, structured the same way every week, ready to present without any manual cleanup. Validating the pipeline. Now, before letting the agent run continuously, it has to prove it can handle multiple days without breaking. Every function so far has been tested in isolation. In live operation, the data structure varies day to day, and small inconsistencies that did not show up in a single run will surface across multiple runs. Skipping this step is how an automated system silently produces wrong outputs in week 3. The validation instruction tells the agent to pull the last 3 unique simulation dates from the purchase order data and treat each one as the current day. For each day, it runs the full daily pipeline and prints the formatted brief tagged as a test iteration. If any of those dates falls on a Friday, it also runs the weekly logic. It builds the Excel file and verifies it opens cleanly. The pass criteria is that all 3 iterations have to produce real numbers, no exceptions, no empty rows, no null values in one continuous run. On the first attempt, the agent catches a real bug. The gross margin field in the source data is stored as a string with a % sign, which means the anomaly logic for margin checks is reading text where it expects numbers. The agent identifies the failure. It implements a parser that strips the % sign away and converts it to a float and restarts the validation from the first iteration. And that restart behavior is exactly what the instruction defined, and it's the difference between catching the issue here and catching it 3 weeks into production. On the second pass, all 3 iterations are clear. 3 daily briefs produced, all numbers populated, All anomaly references valid. The pipeline is verified across multiple days, which now means it's ready to run on its own. Activating the loop. Until now, the agent has only run when I told it to. The continuous loop is what turns it into a system that watches for new business days on its own and processes each one exactly once and only triggers the weekly cycle on Fridays. Now, the loop logic even is direct. The agent polls the data source every 30 seconds and pulls the latest simulation date. If the date matches the last one it processed, it skips the cycle and goes back to sleep. If the date has changed, it runs the daily pipeline and sends the brief to my WhatsApp. Then it checks the day of the week. And if it's a Friday, it also runs the weekly pipeline, builds the Excel file, and sends it to the same WhatsApp number. After processing, it stores the date so that the same day never gets handled twice. Errors get logged and the loop backs off for a minute rather than crashing the whole agent. Now, a heartbeat line prints every 10 polls, so I have visibility that the agent is alive on quiet stretches. I send the instruction, the agent confirms the loop is running, and almost immediately it detects a new simulation date. Now, without me triggering anything, it runs the full daily pipeline for April 2nd. It sends the brief to my WhatsApp and it goes back to polling. I check WhatsApp and then the brief is there, it's formatted correctly, it's populated with real numbers. So this is the first cycle that the agent has run on its own. To prove that the system will continue to do so, I let it process the next 2 weeks of business activity without touching it. As new dates appear in the source, the agent picks them up, processes each one in order, and delivers the output. April 3rd and 4th come in together because the agent was polling fast enough to catch both updates in the same window. It processes them sequentially, daily brief for April 3rd, then April 4th. April 4th is a Friday, so the weekly pipeline triggers automatically alongside the daily one. The messaging channel shows the daily brief and the Excel attachments side by side. The first weekly pack is in production with the executive summary showing margin pressure as the headline issue and the actions tab carrying recommendations tied directly to that finding. April 5th lands on a Saturday. The agent sends the daily brief, but it skips the weekly logic, which is what the day of the week check is supposed to do. April 6th and 7th process back to back as separate days. The numbers shift across the days, revenue moves, procurement spikes, anomaly counts change. Same brief structure, every cycle, only the data is different. April 9th is the edge case. Now, revenue drops to zero while procurement and inventory continue to move. Some automated systems would either fail on the empty revenue field or print a malformed message. This agent produces a clean brief, flags the situation through the anomaly section, surfaces the working capital impact, and then just continues without breaking. So that is the validation step paying off. The structure holds even when the data does something unexpected. At this point, I notice the loop is occasionally batching 2 days in a single cycle when the source updates faster than the cadence I want. I slow the source update cadence so it writes a new day every 100 seconds instead of every 70. Now the agent picks up exactly one new date per cycle. April 11th arrives on a Friday and triggers both pipelines together for the second time. The weekly pack now reflects 2 weeks of business activity with trends extending across the prior week and the current one. From April 12th through to April 17th, the agent runs in pure daily mode, each day picked up individually. The content varies meaningfully. Some days lead with stock out risk, others with margin pressure, others with hash cycle deterioration. April 18th is a Friday and triggers the third weekly cycle. Now, by this point, the system has processed roughly 19 days of business activity end to end without intervention. Around 15 daily briefs, 3 weekly Excel packs, and 1 real edge case handled along the way. The validation step caught 1 bug before going live, and the loop has not failed since. And that is the full build. OpenClaw on Hostinger as the hosting and orchestration layer, Claude as the intelligence inside the agent, a continuous loop that watches operational data, daily briefs landing on my WhatsApp every business day, and weekly Excel packs delivered every Friday. All without me opening a chat to trigger it. Now remember, if you want the prompts, the workflow files, and the setup instructions from this video, everything is in my free community and it's linked in the description below. See you next time.